Hi all, in this video we're gonna discuss about computer vision related tasks. One of the tasks is supervised contrastive learning. Contrastive learning. So actually it beats softmax in terms of feature learning. So we are gonna build a complete column notebook that compares standard softmax classification against supervised contrastive learning. And then we're gonna visualize the embeddings and see which gives better downstream accuracy. So firstly we're gonna import required libraries. So then we load fashion MNIST dataset to define a encoder projector for contrastive learning. And then we're going to pre-train with NT XNT loss, and we're going to visualize the learn space with PCA and freeze the encoder and train a linear classifier, and we are going to finally compare the results with confusion matrix. So after importing the required libraries, we're gonna set the seed as 42. So here the reproducibility is the key. So we fix NumPy and TensorFlow seeds. We'll use a large batch size of 1024 for contrastive pre-training and contrastive methods, which benefit from more negative samples per batch and a smaller batch of 64 for fine tuning. We'll train the encoder for 20 epochs and the linear head for 15 epochs. The projection dimension is 128 and learning rate is 1e to the power of -3 for the atom. And then we load the fashion MNIST and normalize pixels values to 0,1. Then we're going to flatten the 28 cross 28 images to 784 dim vectors for our MLP encoder. So the two pipelines, one with batch 1024 for contrastive training and one with 64 fine tuning, plus a test dataset for evaluation. So these are the three classes: encoder, projector, and classifier. So here the encoder has two dense layers, 512 to 256 with ReLU and ending in L2 normalization 256D features, whereas the projector, which has another two-layer MLP that match features to contrastive space, again L2 normalized. So this separation follows SimCLR style design. And then we have a classifier. It's a single dense layer that maps frozen encoder outputs to class logits for downstream tasks. So here the code supervised NT-XNT loss, we compute a full similarity matrix between all normalized projections, scale by 1 by temperature, then mask out self-similarities and only give positives. Example sharing the same models, we compute log softmax row-wise and average the log probabilities of true positives. Minimizing this pulls same class samples together and pushes different class samples apart. Moving on to contrastive pre-training loop, we define a contrastive train step with gradient tape. So we're going to compute the embeddings, the loss, and apply gradients to both encoder and projector. Over 20 epochs, you will see the loss steadily decreases, signaling the model is learning to separate classes in embedding space without any classification head. Next, let's inspect the learning 128D embedding. We pass the entire test set through encoder projector and then run PCA to reduce to 2D. Then the scatter plot colored by class shows clear clusters. So this is the proof of concept that contrastive pre-training organizes sample semantically. Now we freeze the encoder and attach our simple linear classifier, and then we're going to train it for 15 epochs using standard sparse categorical cross entropy. You'll notice the training accuracy jumps to around 95% and test accuracy hovers around 90%. So it's kind of surprisingly strong for such a simple backbone. And finally, we predict on the test set and plot the condition matrix. Most classes show high accuracy, though some visually similar items like shirt vest top mix up. So overall, supervised contrastive pre-training plus a linear head computes with more complex CNNs. So that's it about the video. Thank you.